Welcome to solverfy.
So let's kind of draw what they're describing. So I have a person standing, bent at the waist. It's a horrible picture, but it'll do. So I get the feeling that this picture, here's the floor, is accompanied with a picture in the textbook that wasn't posted, and that's fine. I can at least give you an idea of how to solve it. So the idea is here, so they're bending over, but if we're toppling over, the axis of rotation is actually right here, right? So it's a matter of who's got the most mass that can provide a torque on that axis of rotation. So if you remember, torque is force times R or D, which basically means the distance from the axis of rotation. So let's just say somebody had, I don't know, a lot of weight on their shoulders where it was very muscular, or just, let's just imagine a mass around their neck, right? So that is some distance from the axis of rotation, right? That's our R right there. And in this case, we're talking about just the weight, right? So it's mg. So in other words, the person who is most muscular or most massive above their waist, right? Because that's where you bend. Let's pretend if this were a better drawing, that's their waist, right? So the person who has the most mass above the waist is going to have the greatest chance of toppling over, because they will provide the greatest torque, because mg times r from their axis of rotation. Another way to look at that might be the person perhaps with the longest torso, right? Because if you have a very long torso, let's see here, your legs, and we'll pretend that's about your waist. You have a long torso. Even if you didn't have quite as much mass, you might be able to make up for it with the distance, the r, your r from the axis of rotation. But I'm going to assume that they're not going to give you any crazy looking people like that, no Dr. Seuss people, that, we're assuming that we're taking people with average proportions, right, that don't have super tiny legs and super long torsos or anything funny like that, in which case we're looking just for who has the most mass above their waist at that point.